If you want to solve a system of linear equations, then and if we want to use graphs, then the first requirement is accuracy. So we need a grid so we can read it off accurately, and we can write both of them in standard form, and you can use any method to draw the two graphs. So the fact that you have to write it in standard form, like in the double intercept method, it is not always required to do that step. So whatever method you use to draw the two graphs on the same set of axes, the main requirement is accuracy. So if I look here at the two equations, the first one is y equal to 2x plus 3, and the other one is y equal to minus 2x plus 1. And if I want to solve that, I've already drawn it here. So the red one has a negative slope, so this will be our g, the second one. And the first one will be, I don't see a label there, but let us just name it f. So if I have the graphs of f and g, then we can read it off the, I've indicated the point A there just to show you how it works. So this is the solution of the system of linear equations. We need a value for x and we need a value for y. And in this case, we only have one answer because the two lines are not parallel, they are intersecting only at one point. You can test your answer by solving it algebraically. So the first thing we can do, we can for instance add number 1 and 2, and then the 2x will disappear, then we get 2y equal to 4, so we're eliminating the x, so y is equal to 2, which also corresponds to that value that we have there. And if you plug it back into any of these values, so let us substitute in 1, then we get 2 equal to 2x plus 3. So 2x is equal to minus 1, and x will indeed be minus a half. And this is what we have there on our grid. So this is how we will solve it graphically. The main thing is first to have it on the grid before you can start reading off the solution of that system of equations. Let us just discuss a little bit about the role of m when we solve linear equations, set of two linear equations. So we have two lines, L1 and L2. L1 is represented by y equal to m1x plus c1, and L2 is y equal to m2x plus c2. If m1 is unequal to m2, then in 2 dimensions, these L1 and L2 will intersect in exactly one point. If m1 is equal to m2, then L1 will be parallel to L2. It can happen that they are not intersecting, so there is no solution, but it can also happen that the one line lies on top of the other line. In that case, we have infinitely many solutions. So in this case, here we will have lines like this. In this case, we have a blue graph and a red graph, and on top of each other. The next situation we have, if you look at the slope, if we multiply the two slopes and we get the answer of -1, then we know that line 1 is perpendicular to line 2. Okay, so these are some of the theory that you need to memorize. In this case, the C1 and C2, it will play a role here to decide whether it has no solution. So if it has no solution, then the C1 and C2 will be different. If it's the same line, then the C2 and C1 will also be the same. Then it's exactly the same graph.